Hello, this is Deepika. In this video, I am going to demonstrate simple search application which will print number of search results found. Also, we will see the list of indexes created for the process. First, we download Lucene Core 3.6.2 jar available on the internet and store it in a known location. I have done it from this URL Lucene Core 3.6.2.jar. Then I have created a sample data and stored it in a known path. This is the data I have now. I have created 10 record notepad files. Then I create an index folder in the same path. Now go to Java IDE. I have first created a sample Java project. Click on File and New. You can create a Java project. I have named it as Lucene First Application. My Lucene contents would look in this manner. Then right clicking on it, go to Properties option. In Java build path, through add external jars option, I have included the library Lucene Core 3.6.2 jar file I have downloaded. Then click on apply and then OK. Next, create a package for the Lucene First application. Through this option, right click on source, new and package option. I have given my package name as com.tutorials.lucene. Then I have created a new class called LuceneConstants.java. This class is used to provide various constants to be used across the application. Then contents will have contents stored as a string in it. File name will have string file name. File path will have string file path. And max search is declared as int and defined with value 10. Next, moving on to text file filter. This class is used as a .text file filter. We import the libraries needed with predefined classes and functions. Implement will mean that you are using the elements of a Java interface in your class. Text file filter will be implementing file filter. @override will override the parameters of the parent class. Normally, accept will return the boolean value true or false, but in our case, we'll be returning the path name with ending .txt extension, converting into lowercase. This statement will get all the path names with .txt extension. Next, I have created one more class called indexer. This class is used to index raw data so that it will be searchable using Lucene library. We created writer as an object to index writer. Then I have given the index directory path as string input to indexer. We open the index directory path and assign to index directory object of directory class. It will contain all the indexes. Coming to creating the indexer, we give writer the index directory, apply Lucene version 36 standard analyzer, pass true, and index writer with maximum field length as unlimited. Next, we close the writer instance to clear out the buffer memory. Coming to get document, document instance is created for the document class. Instant content field will be created for field class. Contents will be accessed through Lucene Constants class discussed earlier and will be stored into content field. Similar way, file name will be stored into file name field instance of field class. Then file path. In file path, we apply the canonical path function which will remove the backslashes or any extra content in the path. Next, we add content field, file name field and file path field into the document and at last return the document. Next, moving on to index file function, we first print the canonical path and get the document using get document function discussed and also add the document for the writer instance. Going on to create index function, the input will be data directory path in string format discussed above and also filter in file filter. It should have the ending with .txt. We create object files and store all files from data directory into it. Then for each file using for loop, we check if the file is in the directory, it's hidden or it exists, it can be read and it is in the accepted form, that is .txt ending. Then at last we return the number of documents verified through the writer. Next, moving on to searcher.java class. We use it to search the indexes created by indexer and search the requested contents. We create instances for index searcher, query parser and query. For searcher, we give input index directory path as string. We open the index directory path and store into index directory object created for directory class. It will have all the indexes. Next we input index directory into index searcher. Then input the query we enter in the search box to the query parser. It will parse the input contents into Lucen's readable format. Coming to top docs, the search function here will have input search query in string format. The index searcher here will first hit the index database and return the max search declared contents. We have declared max search as 10 in LuceneConstants.java. So we would get the top 10 documents displayed. Coming to score doc, this will get the documents with top hits from the indexed database. Index searcher here will hit the database and gets the documents related. Next we close the index searcher instance to clear the buffer. Next I have created LuceneTester.java class. This is used to test the indexing and searching classes discussed earlier in the Lucene library. We first store the input data path and output data path in string variables. Next declare indexer and searcher instances. In main function, tester is created an object to Lucene tester. In try block we first create tester instance, then we declare create index function. Moving on to definition of create index, we first input index directory into indexer as input, then declare num indexed as integer. We note the start time along with the milliseconds, and in create index we pass data directory and text file filter as input. It should ideally give the number of files indexed and it is stored in number indexed. We note the end time along with the milliseconds and close the indexer instance. We first print the number of files indexed and also the time taken using the arithmetic operation end time minus start time. Next, moving on to search function, we have given input as Mohan. So the search query input would be Mohan for search function. We give the index directory as a string input to searcher. We note the start time along with the milliseconds, and using top docs, the search functionality will search for the documents which have Mohan as a word in it. Then end time will be noted along with the milliseconds. We print the total hits of the documents where Mohan is located and also the time with the arithmetic operation end time minus start time. Then using the store doc in get document function, we print the file path where the Mohan has been found. At last we close the searcher instance. When you run the program, you can see the output in console. These are the files indexed. The count is 10 and the time taken is 64 milliseconds. One record has matched with Mohan. The time taken is 17 milliseconds and the record 4 has the text Mohan. These are the files created in index output path for the input data. So in this video, we have taken a look in creating simple search program to print the search result found. Thank you for watching the video.